Welcome to this class. My name is Italma, and I will be your instructor. The main goal of this class is to introduce you to a range of mathematical tools from discrete mathematics that are key in computer science. In this first lecture, we're going to go through the course administration, what CSC1500 is all about, and we'll take a quick look at the course syllabus and the Blackboard contents. So let's take a look at the course administration. So this class is offered on Tuesdays and Thursdays weekly, and we will be meeting between the hours of 1:30 through 2:50 p.m. and thereafter we have the course labs at JC127. Please do shoot me an email should you want to come to see me in person. My email address is italma.italma@wayne.edu. In this class, for our office hours, we're going to make use of the Blackboard Collaborate. So we'll meet between the hours of 10 a.m. through 11 on Thursdays. And this is by appointment, so you should send me an email should you want us to meet on Thursday between the hours of 10 through 11. And if this time is not convenient, I'm going to create a poll whereby we will decide on a better time during the week when we could have the office hours online using Blackboard Collaborate. So in this class, you're going to you have about 11 homeworks, and you also have 3 examinations. Your first exam is on the 6th of October. Please do write this down. And the next is on the 10th of November, and the last on the 8th of December. You should already have this in your Google Calendar. And the homework has a percentage of 25%. The first exam for 25%. The second and the third exam is also 25%. So the homework is very important. It is the best way for you to learn the course materials. Homework should be handed in the class, and ensure that you do not submit your homeworks late. And late submission will not be accepted in this class. So more details on the homework policy will be found in the course syllabus. So please do ensure that you read your course syllabus. The textbook we will be using in this course is a Discrete Mathematics and its Applications by Kenneth H. Rosen. Please do ensure it would be nice for you if you could purchase this book. It's not really compulsory, but if you have it, it will also serve as a good tool in the course of the class. So this class is basically about discrete mathematics. Why is it computer science? And these are the things you're going to learn through the course of the class, and we'll focus more on the mathematical techniques for discrete mathematics. So this class is about life. Life consists of continuous variables. Numbers are either continuous or discrete, and the same applies to colors. With modern computers, various things are approximated, which means they are digitized. We will focus on discrete variables, how discrete variables are used, processed, and applied. So the topics to be discussed are all in the course syllabus. I will give an overview of a few topics here. So in the first class, we're going to look at set theory. This is a branch of mathematical logic that studies sets, which informally are collections of objects. And we would have a good overview of set theory in the class. Also, logic is one of the topics that we will be covering. So, what does all this mean? How does this actually work? Not to worry. We'll find out in the class. How do you communicate with computers? So signals from the mouse are based on location, your mouse, the pictures are based on pixels values, and the pixel values could be discrete values or continuous values. Continuous values or continuous mathematics are basically real numbers, and discrete mathematics are basically integers. So we'll be dealing mostly with integers, ones and zeros. And for processing, we'll use operators like your addition, subtraction, division, multiplication, or the modulus operators, or sometimes called the remainder operator. We'll take a look at that. And you would also explore how to convert algebraic expressions to logic circuits. So I hope you already have a bit of a background in electrical circuits theory, but if you don't have that, still that's very much fine. We will consider what the logic circuit does with the input based on the different ways of processing, such as simulating a Christmas light. So the other topic we would cover is algorithms. You should already know what an algorithm is because you've taken CSC 1100. So we will be able to solve problems like how to implement a program that outputs 100 based on the integers between 1 and 100. Also output the number of possibilities. So if I may ask you, what would be the number of possibility? What is it? Well, it's obvious. The answer is 50. And we would look at how we derived 50. So there are many ways of implementing an algorithm. And one of the things you will look in an advanced class is the time complexity and the space complexity. Now, the next topic that we're going to cover is database. So database is basically a collection of information which you can extract or query what you want. And we will study the use of relationships and functions. When I talk about relationships, I'm not referring to boyfriend, girlfriend relationships. And we will also study the concept of big data and cloud computing. We'll basically just, on a high level, understand what big data processing is all about and what's the noise about cloud computing. And for big data processing, I'm going to show you, as regards big data, I will introduce you to a platform called the High Performance Computing Cluster Systems, which you can use to extract or query what you want. So we're going to look at this wonderful system which is designed for processing big data. And the next topic we're going to cover is formal proofs. So these are parts and more of the topics we will explore. You will also explore how to write statements rigorously, how to read and write theorems, lemmas, etc., and how to write rigorous proofs. But remember, practice makes perfect. And take note, learning to do proofs from watching the slides or listening to me speak in class is like learning it's like trying to learn how to play tennis from watching it on TV. So do exercise, all right? And by the way, we are not after the shortest or most elegant proofs. Verbose but rigorous is just fine. And on the topic of playing tennis, if ever you want to play tennis with me, please send me an email and we can meet at Belle Isle to have some fun playing tennis. All right, so the other topic we're going to cover is probability and counting. These are various applications. There are various applications of probability, which are used in machine learning, data mining, robotics, image analysis, natural language processing, and many others. Well, we'll look at why probability is really important and also counting. And also we'll look a bit on Bayesian reasoning. Bayes rule is one of the topics we'll breeze over. And then the other topics we're going to cover is matrices, graphs, and networks. Now, matrix is very important for computer scientists, and also graphs. And these graphs can be represented as matrix. basically. So graphs are a bunch of nodes and nodes connected by lines, or sometimes called edges. Graphs are applied in distribution problems, routing problems, maximum flow problems, telephone, and of course the internet. And so networked or linked structures are ubiquitous. Examples range from the World Wide Web, large social networks such as the network of friends on Facebook, or even a neurological network of the brain. And some of you might want to venture into neuroscience, machine learning. So you deal a lot with the use of graphs. And on the topic of graph, we will also look at the application of coloring problems to determine how to color this map so that no two adjacent regions have the same color. And this is a very fun topic. You would enjoy it. And also we would explore various representations of graphs. We'll look at how to find the minimum path through a graph, and also an example of an application of graph is the graph coloring. An example of graph coloring is the scheduling of final exams, say in Wayne State University, such that no student has two exams at the same time. Now, how can we create such a schedule where there are no conflicts of exams for a student at the same time? Now we can use the graph coloring problem to solve this problem. And an example is here. So for example, given seven courses based on this graph, the number of possible time periods to ensure no student has two exams at the same time is 4. And to understand what this graph is all about, you can read the descriptions here. A vertex corresponds to a course. An edge between two vertices denotes that there is at least one common student in the course they represent, and each time slot for a final exam is represented by a different color. We are going to explore this in great detail, and you would enjoy this topic so much. So we'll also look at the traveling salesman problem. This is a problem which is discussed in artificial intelligence. It's a very nice topic, and we'll also explore the minimum spanning tree. We will explore dynamic programming to find the minimum or shortest path of a network. This is a fun topic, and I look forward to it. So that's it about the course administration, goals, objectives. So next, let's look at the Blackboard content. So here is the course Blackboard page. Do ensure you go through all the content. Please do read through all the announcements that I will be posting through the course of the semester. And do go through the welcome start here. I have created for you a course orientation survey. Please, I would deeply appreciate for you to fill this survey, because this will help me to teach you better during the semester. You can also go through the course syllabus, which you have on this tab. So here's the syllabus. You can read through you can download the PDF to read through your PC, or you could directly just read through the syllabus here. So I have created a course content that would guide us through the semester on the topics that will be covered, and when you have your assignments. And I also included the lab sessions, so when you would have your first lab and your first assignment. So your first assignment will be on the 13th of September, and you also be having your first lab. So between now and the 13th of September, I would want you to familiarize yourself with the MATLAB programming language. It's a wonderful language which we're going to use in solving various problems in discrete maths for the lab session. So here are the various topics that we're going to cover, and like I said earlier, you have 3 examinations, and you also have 11 assignments, of which I'll be grading your best 10 assignments. And please do read through the grading policies and everything in the syllabus. If you have any question, I would appreciate that you contact me, and you have my contact details. So do ensure you take note of my contact details and send me an email when the need arises, when the need is greatest. So as your instructor, I'm basically here to help you succeed. Anytime you need assistance, please do not hesitate to contact me. So, welcome again, and I look forward to working with you in this class.